Hello everyone, this is Joyita Ghosh. Today we will explore K-means clustering, a fundamental technique for uncovering hidden patterns in data. Throughout this presentation, I will cover what it is, how it works, why it is useful, and some of its limitations. So let's begin. Clustering isn't just a machine learning concept. It's something we see in real life every day. For instance, when Spotify suggests playlists based on our music tastes, it's clustering our preferences with those similar users. Uber cluster drivers into areas to balance supply and demand more efficiently. Netflix uses clustering to recommend movies that people with similar viewing habits have enjoyed. In all these cases, data points are grouped based on similarity. The goal is to discover hidden patterns without any prior labels or training. Now, what is K-means clustering? K-means is an algorithm that groups data into K clusters based on similarity or distance between points. It's unsupervised, meaning it works without labeled data. From the figure, we can see there are unlabeled group of data. After K-means, they constructed two groups of clusters. Each cluster groups together data points that are closer to each other than to points in other clusters. The algorithm tries to minimize the total distance between each point and its assigned cluster center. Here's the mathematical formulation we want to minimize. We sum up the square distances between every data point and its cluster centroid. K is the number of clusters and Ci represents the points in cluster I and mu I is the centroid of the cluster. In simple words, K-means keeps adjusting the clusters to bring points closer to their centers. Now let's see how the algorithm actually works. First, we take all the data points we want to cluster. Then we randomly pick K points at the starting centroids. Next, each data point is assigned to the nearest centroid. As we can see from iteration 1, each data point is assigned to its nearest centroid and constructed two clusters. Then we recalculate the centroids by taking the mean of all points in each cluster. This process repeats, assign and recalculate until the centroids no longer move. This is how K-means finds stable clusters. One challenge with K-means is deciding on the right number of clusters. How many Ks to have? That's where the elbow method comes in. Guessing isn't really reliable. We run K-means for different values of K and plot the within cluster sum of square, essentially the errors. Within cluster sum of squares measures how well the data points are clustered around respective centroid. As the graph appears, K on x-axis and WCSS on y-axis. As K increases, error decreases. At a certain point, adding more clusters doesn't significantly reduce the error anymore. And the curve forms an elbow. This point is usually the best choice for K. It helps prevent both underfitting and overfitting the data. Finally, let's see the strength and limitations of K-means. On the positive side, K-means is simple to understand and implement. It's computationally efficient even for large datasets. It works well when the clusters are spherical or clearly separated. On the negative side, we have to manually choose K and sometimes the elbow method isn't clear. It's sensitive to outliers because they can pull centroids far away from where they should be. It struggles with clusters that have irregular shapes like moons or spirals, which limits its flexibility compared to more advanced clustering algorithms. Thank you so much for your attention. I hope this gave you a clear and simple understanding of how K-means clustering works.